4.5, graphing other trig functions. We're going to graph y equals secant of x, and we're going to note that secant is the same as the reciprocal of cosine. So in order to graph secant, we're going to graph cosine. 1, 2, 3, 4. The period is going to be 2 pi. 1, 2, 3, 4. So we're going to go from negative 2 pi to 2 pi. And we're going to graph cosine. So we're going from negative 1 to 1. Cosine starts at 1, then hits 0, negative 1, 0, and 1. So 0, negative 1, 0, and 1. This is the graph of cosine. And since secant is the reciprocal of cosine, wherever cosine is 0, secant is going to be 1 over 0, or undefined. And that means we're going to have a vertical asymptote. So anywhere cosine is 0, we have vertical asymptotes. And then the reciprocal of negative 1 is negative 1, and the reciprocal of 1 is 1, so they're going to have those points in common. And then to finish out the graph, we're just going to turn cosine upside down. So we're turning cosine upside down in between the vertical asymptotes. Y equals cosecant, which is a reciprocal of sine. So to graph this one, we are going to graph sine and then turn the graph upside down. So we're going from negative 2 pi to 2 pi. We're up at 1, down at negative 1, and we just have to graph sine. So here's 1 period of sine, and then maybe we'll go 2 periods with this. So here's 2 periods of sine. Anywhere sine is 0, cosecant is going to have a vertical asymptote. So here are the vertical asymptotes, and then we just turn sine upside down in between those asymptotes. Let's graph y equals negative 2 secant of x plus pi over 2, and we're going to graph negative 2 cosine of x plus pi over 2, and then we're going to turn everything upside down. So let's graph cosine. 1, 2, 3, and 4. 1, 2, 3, 4. So negative 2 pi to 2 pi, and we're going up to 1 and down to negative 1. Now the negative reflects over the x-axis, and we're actually going to go up to 2 and down to negative 2 because we have a new amplitude, or this has been stretched vertically by 2. Well, cosine would normally start at the highest point, but now cosine is going to start at the lowest point. And go to 0, 2, 0, and then down to negative 2. Whoops, I don't want to draw that yet because we're going to move these because I got to go left. I got to go left pi over 2. So let's just draw the rest of them. We got 0, negative 2. Now, if this is pi right here, then this is pi over 2. So we're going to have to move this left. Everybody moves left 1 space. So this moves left, 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 here left, left 1, and left 1. So now this, let's see, where are we at? Right here. This is cosine. Whoops. Right there. So anywhere this hits the midline, we're going to have this vertical asymptote. And then we just turn the graph upside down. There we go. So turn this upside down, and upside down right there. Y equals 3 plus cosecant of 1/2 x. Well, now the period is normally 2 pi, and we're going to divide that by 1/2. So now our new period is 4 pi. So we're going to make 1, 2, 3. We're going to make the 4th mark instead of 2 pi. We're going to make this 4 pi. 1, 2, 3, 4, negative 4 pi. And we'd go up to 1 and down to negative 1. But we're going to push this up 3. So let's make that 1, negative 1, 2, 3, 4. So our highest point is going to be up there at 4. Let's graph. We are graphing sine. So sine starts at 0, goes up to 1, 0, negative 1, and 0. And then negative 1, 0, 1, and 0. But we got to push all of these up 3 units, which makes the new midline. This is the new midline up here at 3. So we start at 0, we go to 1, 0, negative 1, back to 0. So we have negative 1, 0, 1, and back to 0. So here is sine, And now anywhere this graph is hitting the midline, we have a vertical asymptote. So here, here, and here. And now the actual graph is we just turn this graph upside down in between the asymptotes. Tangent and cotangent. The period length is now pi instead of 2 pi. So tangent repeats itself every pi. And we're going to note that tangent is y over x or sine over cosine. Now we have these vertical asymptotes where the denominator is 0. So in order to graph tangent, we're really going to graph cosine, and then we'll just alter it the way we need to alter it. So we have 1, 2, 3, 4. We're going to go to 2 pi because we're going to start this by graphing cosine. So we're going to go up to 1, and we're going to go down to -1. Now cosine starts at 1, then goes to 0, -1, 0, and back to 1. 0, -1, 0, and back to 1. So this is cosine. And then anywhere cosine is 0, tangent is going to have these vertical asymptotes. Well, now the way tangent acts is this would be pi. This is pi over 2. So this is half of that. That's pi over 4, 4. And we have negative pi over 4. And the tangent of negative pi over 4 is -1. The tangent of 0 is 0. And the tangent of pi over 4 is 1. Now, if we plotted a whole bunch more points for tangent, it would look like this. It curves through, and it's shooting up to infinity on the right and shooting down to -infinity on the left. So now tangent is going to repeat that every pi. So we would have -1 here, halfway, and then this would be the 0. So it would stop here at 0 on this side. And then we could repeat it over here as well. -1, 0, 1. Looks like that. And then we'd have 0 and 1. Let's graph y equals cotangent. It repeats every pi as well. And cotangent is cosine over sine. So to graph cotangent, we are going to graph sine. So up here at 1 and -1, 1, 2, 3, 4. Here's 2 pi. 1, 2, 3, 4. -2 pi. Let's graph sine. 0, 1, 0, -1, and 0. So there's one period of sine. And here's another period of sine. Now anywhere sine is 0, cotangent is going to be undefined. So that's where we have these vertical asymptotes. And then let's look from 0 to pi right now. This would be pi over 4, and this is negative pi over 4. And the cotangent of pi over 4 is 1. So now we're up here at 1. Cotangent of pi over 2 is 0. And the cotangent of negative pi over, or not negative pi over 4, this actually be 3 pi over 4. That's going to be -1. So here is the shape of cotangent. And it looks like tangent turned upside down. It really is. But tangent goes from negative pi over 2 to pi over 2. This goes from 0 to pi. So 0, -1. There we go. And we got a couple more that we could graph over here. So we have 1, 0, -1. Let's graph tangent of x minus pi over 2. And we're going to graph, it's sine over cosine, so we want to graph the cosine function. Move it right pi over 2, and then we'll finish up with graphing tangent. 1, 2, 3, 4. Here's 2 pi. 1, 2, 3, 4, -2 pi. And we are graphing cosine. So we're up at 1, down here at -1. Cosine starts at 1, goes to 0. -1, 0, and 1. And then 0, -1, 0, back to 1. But now I have to push all of these over to the right pi over 2. Well, here's pi over 2. So we're pushing this to the right one space, one mark. So we need one more over here, 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 there, there. That pushes that over, there, here, and here. Now, anywhere this graph hits 0, we're going to have vertical asymptotes. And here. And now we're graphing tangent. So in between those, we're going to be at -1, 0, and 1. So like that, we're going to be at -1, 0, and 1, and -1, 0, and 1. -1 and 0. So it'd be like this, and then we could even have 1 over here where we're at 0 and then 1, and that's another half of 1 over there. Y equals tangent of 2x minus pi over 2. This right here, that's going to change the period. The period for tangent is normally pi, so now the period is going to be pi over 2. And you would think that we're moving right pi over 2, but in order to get that information accurately, we have to factor the 2 out. So we have 2x and then minus pi over 4. So instead of going right pi over 2, we're actually going to move this graph right pi over 4. Tangent is sine over cosine, so we're going to graph cosine. 1, 2, 3, 4. And cosine is normally 2 pi, so when we divide that by the 2, this is going to be pi. So this is pi over 2 right here. 1, 2, 3, 4. So this is going to be negative pi. With cosine, we're going to go up to 1 and down to -1. And cosine starts at the highest point and then goes to 0, lowest, 0, and back to the highest. So we just repeat that pattern on the other side. But now all of these have to be pushed to the right pi over 4. Well, one space is pi over 4. So we need one space over here. And we're going to move all of these to the right one space. So this is cosine. And now we just have to turn everything into tangent. So anywhere this is 0, anywhere this graph hits the midline, we have these vertical asymptotes. And then in between the asymptotes, we're going to have, this is tangent now, so we're going to have -1, 0, and 1. So this is what tangent looks like, -1, 0, and 1. So then we have -1, 0. We just have kind of a half of 1 here. And then over on this side, -1, 0, and 1. And over here we'd have 0 and 1. Y equals -2 cotangent of x. Well, cotangent is cosine over sine, so we're going to graph sine. And the amplitude is up to 2, and we're going to reflect over the x-axis. 1, 2, 3, 4. Here's 2 pi. 1, 2, 3, 4. There's -2 pi, and we're up to 2 and down to -2. Now, sine starts at 0, and normally as we go to the right, we would go up to 2, but now since it's reflected over the x-axis, we're going down to -2. 0, 2, and 0. So we're up to 2, 0, we're down to -2, back to 0. So here is 2 periods of sine, and now anywhere this hits 0, cotangent is going to have these vertical asymptotes. And then cotangent, now we've flipped this upside down, remember, and so it's going to look like tangent because we're turning cotangent upside down. Now, tangent looks like this, like that. That's tangent. And cotangent looks like this, but because of that negative, we've turned cotangent upside down, so it looks like tangent. So -2, 0, and 2. Just like tangent, except this is actually cotangent. So there, and finally there.